Hey everybody, good morning. Buenos dias. ¿Qué tal? Say hi in the chat if you can hear me. And if the video is alright, let's get started. Anybody? Anybody in the chat? Am I finally streaming alone in this room? Okay, meanwhile, I'll show you what I'm gonna break down today. Hello, Antoja. Thanks for stopping by. So I'm gonna break down this website today, Richard Matka. I think this is a pretty amazing one. The animation fascinates me. Getting red when the mouse gets closer to the center. I need to translate this. Okay. Hi to you too. Alrighty. Happy New Year too. This is the second stream this year. So I'm gonna break down this website because I thought this one is a really cool one. You see all those shapes and they've been transformed into the other shape slowly, but you can get an idea if I don't know which part, but it's actually changing its size. All the holes and the shape is changing its size, and the shape is changing its shape. All right, so let's do this. Hi Yana. Finally, this stream is gonna be a bit with a math, but you know, this is a real cool thing to do. I think you can even follow this stream by if you like. I will explain how. So let's get started with my usual template, and then I'll explain how you can follow my stream without using any kind of template. So I'm gonna call folder Matka. I'm gonna get my default template for the three.js scene. I'm gonna open it up in a Sublime. Create HTML, make it bigger. I need a wrapper there, I need to link the JavaScript file, and then I can run it all with the parcel. Make it a bit bigger, I'll run it, and let's see. Why so much folders? So many folders on my desktop? Because there are so many things I've been working at the same time. I want to read some books. I don't want to forget to decompile some other animations, and there are some ongoing commercial projects I'm working on, so I need to have all those folders on my desktop. Probably you're right, I need to clean that up, but for now, they're still there just to remind me. It's like my to-do list on my desktop, constantly reminding me. It's like a stickers on your fridge or something, just to remind you what to do. Okay, it started all, and let's see. Yeah, see the red square. This is perfect. The other thing I will do in my template, I will make this square full screen, so it fills the whole screen. I already have this kind of code here. I'll just uncomment it. I think I explained it in a couple of streams previously, where I made the full screen JLSL animations. So probably now I should see the screen filled with a red square. Yeah. So now it scales a bit to account for the aspect ratio of the screen, and then it moves a bit closer for the camera so it fits the whole screen. Just one minor thing to do is to get rid of this margin, and to do that I'll just do this. I should fill the whole screen now. All right, so fill the whole screen with this red rectangle. And this rectangle is using fragment shader to being colored. What else I could do with this? I have the UV coordinates, and I can just preview my UV coordinates here. This is a two-dimensional vector, so I should see some colors on my screen. Yeah, this is what I see. And this is where you could get into me coding today. It might get a little complicated. Oh, mentarakas, sebiton. Mr. Senko. All right, hi to Finland. Yep. So yeah, that's where you could start coding yourself, and I'll show you how. There's this resource called Shader Toy by an amazing Inigo Giles, and you can just get there, maybe register, but I think you don't need to be registered to start coding here. And you could just do the same thing. Like, this is the most important part. After this part, it's all the same if you code in JavaScript or if you code in the Shader Toy. So to make this part the same, I'll just give you a short snippet. Boom, boom, boom. Where's the chat? Yeah, so if you're following me, you can just use this snippet, and I'll show you how to use this one. Just go here. I'll just make it a bit bigger, like this. So I set some variable p, which should be two-dimensional vector. And then I can preview this variable here, like this, because this is 2 dimensions. This is the third part of the 4-dimensional vector, so-called, and this is the fourth part. So I don't even need this color thing. I just need this speed, which I sent you in the chat. And what else? Now I could just run it. There's a small button to run it. And it doesn't work because I think because probably this is not the resolution, this is I resolution. I messed up everything. What else? This is not I resolution. I think I have this short snippet here as well, so I might just copy paste it. It's just resolution, yeah. This example is actually from the other stream of mine. Just resolution. No. The hell. Starting off with a mistake. I'll copy paste the right code now to you. Why messed up? How do we call it on the Shader Toy? Resolution, undeclared, identified. Okay, it's probably I resolution anyway. So let me just get my minute of debugging now, so I can find out where I'm wrong. Resolution, well, XY maybe. Doesn't quite work the way I intended. Okay, maybe I should just start with enough new. I think they had there. High resolution XY. Okay, it's not GL frag chord, it's just frag chord. Right. So this input vector 2. Yeah, thank you, Shader Inputs. I just forgot. I actually had it all the time right here, but I forgot how to write it down. I resolution, and now it should be good. Well, at least we don't see any errors here. Hello, Ellen. What I messed up again? Probably XY here. I don't even need XY here. Oh, I need it. You know, I don't actually need this part to do the animation I was intending to do. I just wanted to make this part for anybody who want to follow me live coding. So let me check it. Record everything. I don't need this for now. All right, that goes for the screen, but why it's black? The hell is black? I need this, but I still outputting the UVs, right? Okay, maybe just like that. Well, I think that should be enough for now. We can just do this. Just divide. Well, actually, it was happening in the first place. So maybe I shouldn't do anything about this. Hey, to Kiev too. At least someone from Kiev. So you could just use this UV variable as the one I'm using here. Like UV, I'll call it new UV, and you can call it new UV2, and then we could just get started from this. You could preview this new UV as this. So there you go. You have the UV. You have the same preview that I have now in my three.js template. It's just the same. I have a plane with this, and Shader Toy just previews the same thing here. Yeah, I think this is enough. I was trying to overcomplicate things. This is just enough. So I have this UV, I have the same thing here. So if you want to follow my code, you can just write all the code here. All right, let's get started. So first I want to show you just what exactly is this UV. So I can show you some basic fragment.js functions, and that you actually have this fragment shader running for each pixel on your screen, or shader toy, or anything you're using right now. So I'm gonna make the window a bit smaller here, move this a bit. Yep, so well, first let's just declare a new variable, call it, I don't know, black and white. It's going to be equal step function, and then we use new UVX and 0.5, for example. This step function just returns either 0 or 1, depending on which value is bigger, like 0.5 or or UV coordinate. So UV coordinates is just the system of coordinates on my screen right now. So if I try to show what's that black and white variable is, it's not going to be black and white now, it's going to be red, because I'm using the red channel of my RGB. This is, you'll see this, and well, depending on if I change the variable, it's going to be just filled with 20% probably. What? Why did it disappear? All right, never mind. So I can, depending on the value of the UVX and depending on the same value of the UVY, I could just fill my screen depending. And so it's just some functions. This function actually are being run for each pixel of my screen. This is what the idea I want you to understand. You can just try this thing and see that it actually works for you. So you see half of the screen, or maybe 60% of the screen filled with something. Yeah. All right. Next thing, to do this animation, I think Richard used three.js for this one. Yeah, he did. One of the recent versions of the three.js. But how did it make his shape, like this weird shape, which is actually changing its forms constantly and being interactive also? It's not a usual obj file, not some GLB, GLTF file. This shape is actually made programmatically with a Raymarching technique. And this Raymarching technique is one of the most fascinating things I know about shaders and visual programming at all, because, you know, it really fascinates me how you will see that this shape is actually made with just one line of code. Like exactly, just one line of code. But let's get there. we need to do some math before we get there. So what is Raymarching essentially? I just told you that we have this function with shader running for each pixel of the screen. So Raymarching is just, we should imagine that for each pixel of our screen, we send some ray through this pixel. Like it starts with the camera, then it goes through the pixel on my screen. This is a pixel on my screen. Imagine this is your desktop, your viewport now in the browser. And you get this ray coming from the camera through these pixels, and you have a bunch of those rays. And because we have the shader running for each pixel of my screen, I can actually, on each fragment shader calculation, I can just do something with this ray, right? So I have then some object on my scene. So if this ray goes past the object, I shouldn't just show anything. But if this ray comes into the object, I will just show some color. This is it. So I'm going to check if the ray intersects with the object. To do this intersecting part, there's another technique called signed distance fields. So I will describe this shape as a mathematical function. It's not going to be some object. It's not going to be, you know, some cloud of points that I will declare, like thousands of points in the form and shape of the sphere, but it's going to be just the mathematical formula which describes the set of points on a sphere. I actually had this stream, if somebody speaks Russian, I had this stream on season 2, episode 6 on Raymarching, where I did this animation where the sphere is morphing into the square and then back again, and this is infinite grid of those objects in the space, and it's pretty cool. And that's where I started to be fascinated by this idea, by this whole idea of the Raymarching. So I could just copy paste some part of this, but I will explain them one by one. So first of all, I think I will need to set some camera, and I will need to set some ray. So if you saw this on this image, on this preview, yeah, because most of the people of the world speak English, that's the reason. And I need to practice my English because it's shitty. I need to get better in my English. Yep, I might stream in Russian later on, probably just a little. So let's get on to this. So I need to set the camera, I need to set this ray, and then we'll start from there. Boom, boom, boom. So I'll just set like camera position. It's something in 3D space, so it's going to be vector 3 with the 3 coordinates. That's something like camera position. By the way, I can just send you these links, so you might want to, I don't know, preview it. You might want to copy paste something, because I'm going to be, some parts are going to be just the same as in that stream. So I'm going to set the camera position somewhere in 3D space, and I'll set it like a bit off from the 0, 0 point from the start of the coordinates. I will never forget about streaming and finish. Okay. So it's somewhere off the 0 point, because I will position all my objects in a 0, 0, 0 point. So that's 3D space. So I'll set the camera position to this. It's 2 at the 0 axis, and it's 0, 0 for x and y axes. Okay. The next thing I want to do, I want to calculate the ray. And it's actually quite simple. I will calculate the ray as a, again, 3-dimensional ray, or the vector is just vector 3. And then I'm going to do what? Ray. I need it to be with a length of 1. That's why I need to normalize the vector. Normalize function just makes the vector length 1 unit vector. How do you call it in English? So if the vector was like 0, 0, 10, it's going to be 0, 0, 1. And if the vector was 0, 1, 1, it's going to be 0, then square root of 2, something like that. Just so the length of the vector is going to be still 1. Normalize, and then again, vector 3 here, uv, -1. -1 because I want this vector to point backwards into my 0, 0 position, because I'm being, as a camera, I'm being at this position, 0, 0, and +2. So to point the vector backwards into the 0, 0 position, I need to set this -1. And then this part is actually, describe it right here, is actually this point on my imaginary plane, which I'm using to make a vector from the camera. So this is this vector, which is shown as red here. This is it. This is the ray I'm making. So it's just the direction in which we should go every time and check if we intersect with any kind of objects in our scene. So far, I think it's understood. So we have the camera in some position, still imaginary camera. We have the ray being sent from this camera. Now what else we do need? We need an object in my scene, and we also need to check the intersecting part. So to check the intersecting part, usually the loop is used, and there's another preview. This is not yet exactly the Raymarching technique. The Raymarching is actually this. Show you. It's an algorithm. It's a pretty nice one. So for example, I'm sending the ray from P0 point this direction. So I need to check if this ray intersects some kind of 3D objects in my scene. So first I'm calculating the distance from this point to the closest point in my object. And this is it. This is this point. This is the distance, you see? This is it. So then I'm drawing an imaginary circle and take the next point on my ray exactly on this direction. And this is the ray. The blue one is the same as the ray that I just calculated. So I set this point and then calculate the distance from this point, like the shortest distance from this point to my object in my scene. So this is the second circle now. Then I'm moving on my ray and calculate the next one. And I do that until this circle gets real small. So at the end of right here, this distance is going to be real small. It's going to be smaller than 0.0001. And that means that I actually hit my object in my scene. So I didn't hit it right here because I still had some distance from my point on the ray to my object. Well, I hope this is understood because I'm trying my best. Let me know if you don't. I'll try to explain it better. So this is just an imaginary abstract algorithm on how you can check if you intersect something in some direction. So to do this in my shader, I need two things. I need some function which calculates the distance from any point on a space to my object, to my scene, to any kind of objects contained in my scene. And the other thing I need to do this calculation. I need to make a loop to go in direction of my array and to get the new points and to check for the new points. So this is a pretty common technique for anybody familiar with the Raymarching, but I'm just trying to explain it to the guys, like the web developers who spend their whole day working with React, or maybe even with React Native or some kind of this weird stuff, and they don't know anything about those graphics techniques and how to call Raymarching. This is a cool principle, you'll see it a bit later. So let's make this loop. Let's start, let's introduce another variable which we'll call the ray position, and I'm gonna each next point is gonna be updated in the loop, and it's gonna be ray position. So the first ray position is actually the start of the ray, and the start of the ray is camera, because yeah, this is the start of the ray. You see, this is where we start. So I'm gonna introduce new variable called ray position, which is equal. No, I think I had just one project with Babylon, but I don't really have much experience with Babylon. But once you get into the shader stuff, it doesn't really matter which framework you're using, they're just the same, even on the iOS or OpenGL, it's just the same damn principles. Okay, so the first ray position would be just the camera position. And then I'm gonna have the loop. Okay, I don't have snippets here. I'm gonna just write that down. Int y equals 0, and this is, I think, the only place where I don't actually need to put a dot after this one, because this is an integer. And then till I minus equal 64 usually used. Somebody use 100. I don't think it matters now. Yeah, WebGPU is cool. It's not only by Apple. I think it's been standardized now, so you can use it anywhere. So for each next point, so I need to calculate the next point. To do this, to calculate the next point on my array, I need to calculate the closest distance from the point of camera position for now to my object. To do this, this is exactly what signed distance fields do. So signed distance field is a function which essentially returns you the distance. This is a distance function. So for each point in space, it just returns you the distance for your object. Yeah. So it's in math, but it doesn't really matter. Determines the distance of a given point x to the boundary of something. You can call it a scene or object or anything. So this is some function which returns the distance. So let's introduce the function called sphere. It's going to take some position in a 3D space, and it's going to return me a distance. So the distance from the sphere radius 1 is going to be just this. It's easy as that. So this is the function that draws sphere on my scene. And let's introduce the scene, because this is the object and I want to make it a bit just one more abstract layer and call it scene. I spent way too much time explaining Raymarching, so hopefully you understood that. I hope we can still make it for the whole animation in this stream. So on the scene, it's going to be taking again same point and just going to return sphere P for now, because I might have some other objects in my scene, not just this one sphere. So this is simple as that. There's a nice article from the Iniko Gilles on the signed distance field objects, and yeah, you can just Google distance function, and they have all kinds of those distance functions. Like you can draw a rectangle, you can do a plane, like these weird kind of shapes. This is a carrot or something, yeah. So you can draw all kinds of shapes with the math. And the simplest one is actually a sphere, and this is what you get for a sphere, where S is the radius of the sphere. Well, I just used it as a hard-coded one. All right, so how to see this sphere? So first of all, I need to calculate the distance from my point to my sphere. And because we already know that, let's make it float car distance equals 0. And then in the loop, we're going to update it. So car distance equals just the scene and ray pos, because ray pos is the current position on my array, and scene just returns the distance from any given point in the space. So current distance is this, it's just this, simple as that. Okay, next part. So now I need to calculate the length of the ray. I need to step in the direction of my array some distance. And how do I do this? I think I'll just do another one, ray length. It's just ray length, and it's going to be the length of this ray that I sent from the camera, from P0, 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 P0. Okay. Now this is funny. Okay, so I'm gonna add ray length. I'm gonna add up something to our length, and I'm gonna add the car dist. Simple as that. So I'm gonna step on my array, some distance on my array, and then I need to calculate the next ray position. I need to step. I need to step on my array further, and to do that, I will just do this, like next ray position equals cam position, which is the start of my ray, plus ray, this is the direction. this is the direction. I need to multiply it with the ray length. So this is actually essentially just stepping in some direction, some distance in some direction. So what I'm doing here, I'm just translating my next point here. So I calculated this distance, I know the direction, so I'm multiplying direction with this length, which is the distance to my closest object, and then I'm going further in my array. So there I have the next point, and I can calculate the distance from this next point. So what next can I do? It's like one of the final parts of making the Raymarching technique. I'm not going to explain it further. This is the first stream in English about Raymarching from me. There are a bunch of nice videos out there, and one of the best ones, by the way, the Art of Web. How do you call it? The Art of Code, I think. This is an amazing setup. Yeah, this is an amazing channel. I can't stress enough how good is this one. It does a much better job in explaining what Raymarching is, and it has a lot of demos for the shader toy and all this Raymarching for dummies. I think you should check this definitely. It's the Art of Code. I'll just post a link. I admire this channel. All right. But I'm just doing my job in trying to explain this in a way that I understand that. Okay, so if the absolute, I mean, it's just the distance of this, because it might be negative. If this is less than something really small, so I'm accounting for this situation now, where I'm actually hitting the object quite close already. Then I could just, let's make a color. Color equals like 3, 0, just a 0 color. I mean, it means black, and then in the end I'm gonna output this color. So I'm gonna see the black screen now. Yeah, that's the black screen, perfect. So if I'm hitting any object, I'm gonna set the color to some other color. And hopefully I should see the red. Yeah, I almost do that. It's not exactly centered because I'm not using the normalized coordinates. I have the UV, which runs from 0 to 1. So to make it better, I think I just make this. I introduce this finally p variable, and I call it p equals what? Minus. So I'll make it so it contains a 0 at the center of my screen. And instead of using UUV here, where I calculate, I don't need this black and white thing, where I calculate the ray, I'll just use P. So there you go, I have this sphere on my screen now. I think I messed up a bit with proportions in my template. I think it will be all right for you in your example, but I have this weird calculation of the aspect ratio in my screen, and that's why it's not really a perfect sphere for now. Okay, so let's get started with the real 3D stuff now. So we have the simplest Raymarching technique where I'm trying to hit the object. I can make the sphere a bit smaller. For now, the radius is 1. I can make it 0.5, so it fits into my screen. So this is actually a 3D object, and this is essentially this. We just did this image. We just hit in some sphere object inside my scene with those rays, and we see if it hits, we just output the red color. So it's like the most important step in this whole stream, that this is actually a 3D imaginary, but you know, everything is imaginary on your screen, 3D object in your screen, but it's actually just a flat two-dimensional plane, and I'm using the shader to calculate this whole 3D stuff inside this plane shader. You know, it kind of explodes my mind that it's actually just the plane which is using the shader to calculate this stuff, and it actually shows you how capable shaders are, of how many crazy things you can do with the shaders in any plane object. And just the plane object, imagine if it's not plane, you can do even more crazy stuff. let's get started. It's not yet a 3D, just a red freaking circle on your screen. You don't really see it red. But I'll just copy paste some code from the previous stream so I don't get repeat. There's this get normal function which I can use, and which is actually pretty simple one. I'll just copy paste it and explain it to you. Yeah, so get normal function, what it actually does, it takes the point in a space, and I'm using some real small value, O, I call it O, just so it has 0 and has a real small value. And then just calculate the vector, which is going to be a normal vector for my scene. So I'm just adding this small value and then subtracting it, and I'm declaring this vector, and this is going to be the normal vector for each point of my object in my scene. So when I hit the sphere in my scene, I could, where's the sphere? I could calculate the normal in that position. So when I really hit it, I'll do this vec3 and get normal at the ray position, because I just hit the object in this exact point ray pos in the 3D space. So I need to calculate normal at this exact point. And then I could use this normal to introduce a lighting to the scene. So let's make a light called light. Essentially is just some point in the 3D space which emits light. So it's going to be 1, 1, 1, for instance, and somewhere that it's positioned diagonally. And now I need to calculate the lighting. And the simplest diffusion lighting is going to be this diff equals, what's that, dot product between normal and the light. And then instead of just outputting 1, I can output something like this. Let's see. Yeah, so we got the basic lightning now. It's somewhere like diagonally positioned. We can move the light, I don't know, X from the left. It should come from the left now, right? So now you see it's a real 3D object, and we're hitting this object with our rays, and we're calculating the normal in each position, in each point of this 3D object, and then we calculate the color depending on the normal and the lightning. Well, I hope I do. I'm doing my best. All right, let's get on with this. This is just the start of the most awesome part. So instead of introducing just one object, I can add some more objects to the scene. So this link, we have the rectangle. So let's try to make a rectangle. I'll just copy paste this function. So we have the signed distance function for the sphere. Now we have the signed distance function for the box. Could you imagine that we actually 80% being here? Probably not, because we just made a sphere, but we're getting there. Alrighty, so let's make it with a square. As the box, I think this is the dimension of the box, and this is the same position of the point in a scene. So instead of just returning the sphere, I would try to return the SD box. I'll comment this for now. It's going to be P and what? P and what? Some dimensions. We should probably see just the red square on the screen. Yeah, because this is a 3D object, but we're looking at it from one direction, so we just see the red. So next thing I would like to do, I would like to make a rotation of my scene. So not the scene, but the objects. Yeah, actually, essentially the scene. So I'll just Google for JLSL rotate function. This is a bit of a math. You don't really need to understand it all. It's just some matrix multiplication. I'll copy paste it here. And has a rotate function which takes some vector, returns the three-dimensional vector again. It takes some axis, like the axis we're going to be rotating about, and we have the angle of rotation. So let's add it here. So I'm going to rotate the system of coordinates. I'm not going to rotate the object, I'm not going to rotate the camera, I'm going to rotate my whole system of coordinates here. So I'm going to make like vec3 p1 equals rotate p, then the vector which we're going to be using as a axis. It's going to be 1, 1, 1. Just some diagonal axis because I like everything diagonal. And then we need the angle. What's going to be the angle? Let's use some hard coded for now. So it shouldn't change anything for now. We should just see the red square, but once I change it to P1, you'll see the square being rotated diagonally. It's been rotated diagonally. I love this word. All right. And I can actually change it to time. Yeah, I think if you're following me on the shader code, it's going to be I time. This is the only difference. So I'm going to divide time by 4, so it moves a bit slower. So yeah, now we have the square with the lightning. What else we could do here with this Raymarching technique? We could combine objects, like combine two objects, which are essentially math functions, into one function. And what function can you use to combine two math functions into one? Well, turns out the simplest one. We can just return minimum of two functions. We can take this one, which is the rotating square, and then we could take the rotating sphere as well. I don't think we actually need to rotate it even. It doesn't matter how you rotate the sphere, right? So instead of returning just the rotated box, I could return rotated box, the minimum of the rotated box and the sphere. And you might try to guess what's going to happen. Well, nothing really happened, but maybe we should make it a bit bigger. Yeah, we should probably make it a bit smaller because it's too big. Let's make it like this. Now you see the square, okay, a bit bigger. So now you see both shapes being combined. So when we use the minimum function, it's a union function. The shape is going to be two shapes combined. You might be wondering what's going to happen if you use the maximum function. It's going to be the intersection of both shapes, which is also kind of nice. It's just the intersection between sphere and the square and the cube, the three-dimensional cube. So you can do all those kind of things. You can use the math functions to intersect them between each other. So let's introduce another function, which is going to be, and I'm just going to make it black and white because I'm sick of this red, everything being red. You can use this, but it should probably work like this as well. I don't know if it works on the shader, so probably it does. So you can just use vector 3 and it's going to populate all three coordinates with the same value. So we're almost there, we're getting there. Next thing I'd like to do, use another function. The sphere and the box are boring, let's use some trigonometry, let's use some sine and cosine functions. So let's introduce some sine crazy, I don't know, vector 3 p, and I'm going to return sine. I already know the function I'd like to use in the end, so I'm going to get you there. I'm going to use sine px plus sine py plus sine pz divided by 3. Call it sine crazy for whatever reason, but what's the error I have there? Syntax error. Missed the bracket somewhere. Okay, probably this. Yeah, JLSL is pretty strict about all those rules. You can't omit the point and comma separators here. So yeah, we're not yet using this function, so let's try to use it. I would like to get an intersection between this function and the sphere. I'm going to use, let's put the sphere first for the sake of, and just going to use p here. Should be good. Let's try it. Okay, it shows me something. It's not, well, it's something. I can multiply p by 2 because the sine function goes like the period of the sine function is 2 pi's. It's like 6, somewhere 6, and the radius of my sphere is actually just 1. I don't really see the sine function in this small area, so I need to multiply p, the system of the coordinates, with some value like 5. see something else. Yeah, it's starting to get there, maybe 10. Yeah, and also to account for the calculation errors, I think I need to divide it by 10 again. So let's just let's make a new variable scale called, let's call it a 10, and then I'll multiply this by scale. Why we are seeing these weird shapes here? Like it's getting weirder and weirder, right? Why do we see it? If you go and try to plot the math 3D plot, something like that, yeah, math 3D.org. If you go to some plotting app and you try to plot some 3D functions, I mean, not real 3D function, but some functions from the X and Y with 2 arguments, I can try to use sine X plus sine Y here. It's 1 dimension less than what I'm using in my technique, but you're gonna get the idea. It's again quite small because this is just minus 2, 2, so I need to multiply this by 10, multiply this by 10. This is what I just did here. I multiplied it by scale, and you'll see this. So this is what you see when you multiply sine and cosine in a flat, when you have 2 arguments. And this is essentially the same thing that's going to happen if I'm using three coordinates. So instead of drawing sphere and the box, I'm drawing some weird pattern in my space, and the whole space is filled with this pattern, and it's either returning 0 or something negative or something positive, and depending on which value it returns, it's actually the distance to this shape. So this is actually the weird shape which fills the whole space infinitely, and it has some kind of this shape in the end. Like it's periodical, but it's volumetric and periodical at the same time. It's kind of hard to explain, but essentially what you see here is this 3D version of this. Yeah, this. And to make it changing, I can just change the scale. Let's make it 30 plus 20 multiplied by sine time, and if you're using shader tool, it's I time. So it's going to change with time now, and you'll see this weird shape. Okay, it's too fast probably. It's divided by 6. So we're starting to see something now. Starting to see the, I don't know, it's crazy what we see. So it's actually kind of close already to the shape I was striving to, but not yet there. A couple of simple steps left. I think also because I know how exactly he made this shape, I will just put some numbers here. So instead of calculating directly this value, I could make it like this. So this value is changing from what? From this is from -1 to 1, -1 to 1, -1 to 1. So all those 3 from -3 to 3. Divided by 3, again, -1 to 1. So if I subtract from 1, I'm going to be going from 0 to 2. All right. And now instead of just using this function as it is, I'm going to do something like this. So it just changes the thickness of my matter, this imaginary matter, because it changes the ranges of the values this function goes through. It changes the thickness of my matter. So all those numbers now, they really matter. Just creating something. And let's see. So yeah, I think it's just getting a bit closer to the shape we have there. Of course, I'm animating it not the same way that he does, but we're kind of getting there. I think also we might change the light position. Maybe it will be a bit better. Light pointing. And I should also rotate it. I'm using this sphere 1. I should rotate it. That'd be a bit better. Okay, sphere is rotating, but I actually need to rotate this one. So there you go, now we have it. It's not yet looking as beautiful as it might, but we have something. Alrighty. Actually, I think I messed up something when I tried it to maybe the lightning. Yeah, it's a trypophobia. So essentially, all those holes you see in the object is this. Like each hole is periodically placed in the volume in the space, and that's why you see it, because the sign is periodical. Alrighty. So the next thing I want to do, I want to close a couple of windows. You probably got an idea of how this works now. And the next part is a bit more complicated. So to color this one, I might use color palettes, and the color palettes from the IQ are pretty amazing, and Richard actually used them too. So there is this mathematical function which can output pretty nice colors. Like you have the function from 0 to 1, like you have some color function which takes the argument 0 to 1, and it outputs some beautiful colors depending on 0 or 1 coordinate. So it's a good way to colorize any kind of objects in your scene, and that's what Richard used. I think he used particularly this one, but I'm gonna copy paste the code. I think I had it, close it, but I had it. Yeah, it was somewhere here. No, probably not. Here, yeah. I have this get color function, which is exactly the function taken from here. You can even see that it's using where is it? Okay, IQ palettes again. So this function used the a plus b multiplied by cosine, and this is what I have here. This get color function. It's just using the some value multiplied by the cosine and some vector here, and it actually outputs the color. So instead of outputting the shadow for now, I will try to output this color from the palette. And let's see what we get here. So instead of setting the vector 3diff, I'm going to do this get color diff, because this value runs from 0 to 1. This is just the shadow value, the color value. And let's see. Actually get pretty weird stuff here already. It's like you're on acid, because the image is being colorized depending on its color. I could also use not the diff value, but the length of the ray position. So it means the distance from the center of the sphere. It means the color of this object will depend on the distance of this point from the center of the sphere. So I can get this length ray pos. And let's see. So it's getting kind of closer. You can see that the inside of the sphere is a bit more light there. We can multiply it by 2, so we get it. This is this gradient. So the closer we get to the center of the screen, the darker the pixels get. And you just travel in these palettes, like which I just showed you. So we're just somewhere here. Maybe we're just using the short, like just this range from the palette. But that's it. Okay, the next thing, which is kind of exploding my mind too. Yeah, it looks pretty nice when you have less of a holes. It's less periodical. So maybe I should just do this. 15, something like this. It's gonna be a bit more beautiful. Yep. Yeah, that looks like a cheese. So instead of calculating the color at each point, I might aggregate colors depending on how close the point is to the actual object. So I have this loop here, which is going. I need to also break here, by the way. I need to stop this loop. It's going to be way more performant now. And I think it's also removed some weird pixels from my object, because I don't need to go until the end of this loop if I already hit an object. If I already hit it, I should just colorize it. All right, it actually looks much better now. and this is real important part. And the final things I need to do, I need to change the way I colorize the object. So instead of colorizing it like with the exact pixel color, I will aggregate those colors. So I will, the default color is just black, it's 0. So inside my loop, until it got to the actual surface, until it got to the break, I will just aggregate my color. So I will add color plus equals, and then I will add this, I don't know, get color. Let's start with this one. So I'm gonna remove this color set. I'm gonna see black now. Yeah, I don't see anything because I have an error in my code, and I'm gonna use this. Do I have an error still? Because I don't have this diff value, so I can probably use this one better, like get color from the ray position, because I have the ray position already outside of this if, and I can use the ray position to colorize something. Yeah, now I'm colorizing it, but it's too bright, I think, because I keep on adding these values a lot in my loop, so it's too much of them. So if I make it less, you can start seeing this weird shape now. So I'm still outputting this color, but now I'm aggregating this color, so it's something better. The other thing I would like to do, maybe it's like this, so it's a bit brighter, so you can play with the values here. But another thing I would like to do, if the ray length more than something big, I don't need to go any further, which is also gives you a nice effect, which you can, I don't know, it was not intentional this time, but it looks kind of nice. What else I might do here? Okay, I wrote myself some notes so I know what else I can do. I can also add the mouse movement, but let's finish with this one. I think to make it more bright, so why this works? So I'm not only coloring the pixels that I'm hitting, but I'm also coloring the pixels that are close to my. Here you see there's a bit of a gradient here going on. I messed up. Why the background is white for me? I think I made some mistake in my calculations, probably. And I need to think which was the mistake. Color. Almost there, guys. Okay. Now I will remove this part. Why this white? Maybe because I'm not clamping the value. Okay, so let's not use the get color, because I think the ray position gets big and essentially all the colors are getting white if it goes further from the sphere, and that's why I'm getting this white background all over the place, because if the ray is not hitting the object, just go in like infinity. So instead of get color, I'm gonna use the other get color amount, and I'm gonna use here the position, probably some kind of position in my 3D coordinates. Same P. And instead of using this amount value, I'm gonna calculate this amount value. I already have it pre-calculated. I'm gonna use clamp function, so it's not going over the 1 ever. So it's gonna be between 0 and 1. So it's not going to the infinity. And here I will calculate like almost the same. I think the values he used was something like this: 1.5 minus length p. Length p is essentially what I just used there. maybe divided by 2. I think that's what he used for the coloring. So this is so I'm gonna get the color depending on the distance from the 0 point, from the center of the coordinates. And if it goes to the infinity, the color will go to black, to the 0, right? Because the length of the P goes like hundreds, and 1.5 minus hundreds is just 0. Oh, I mean, it's minus hundreds. But because of the clamp function, which just makes every number 0 or 1 or between in this range, it's going to be 0. And 0 is just black. So let's try this get color amount here. And instead of clamp, I'm going to just use Raypos here. And let's see. Okay, it's getting there. It starts to look a lot better. I can also make more steps. So when I was moving on my ray here, I always added the whole like the whole distance that I calculated. Like this distance, I just added it to the ray to calculate this next point. But I could make more steps if I multiply this with 0.6, for example. So if I have more steps, this will be a lot brighter. I will need less of a coefficient here. See, it's getting there. Well, this already looks kinda like what we did there, like what Richard did there. We also animate a lot the scale of this function. That's why we have this weird shape, maybe even brighter. Yeah, it's much better now. I think I will translate it. I want to translate it a bit slower because it's too fast to me. And I want to change the scale also slower, like 2 times slower. So we're gonna see this object right now. It's actually kind of what we used there. I'm gonna just add one small thing with a red inside of it. And to add that, I'm gonna introduce the mouse coordinate here. And in the shader toy, well, you might skip this step, or you could use the iMouse variable. It's built in there. So I'm gonna use these mouse events. And then I'm gonna add the uniform here, which is by default a new 3 vector 2 0 0, which is vector 2. And then what I want to do, I want to change this mouse. I think I had it. I'm quite lazy. Raycaster 3.js. I'm gonna copy paste the code from the Raycaster function. I think I had it there pretty much. It's gonna be the onMouse event. The onMouse event. Why? Come on. We're just drawing some stuff in the plane with the shaders. Not much. So we have this mouse handler now, and I also need this variable by default. It's gonna be this mouse, and then let that equals this, and that equals this, and this value, I think it's going from 0 to 1 or not. Event client X, this goes from 0 to 1 multiplied by 2. Yes, this goes from -1 to 1, and this goes to -1 to 1 2. And inside this function I will need that material uniforms mouse value equals that mouse. Perfect. Yeah, exactly, you're right. That's why it fascinates me. That's why I find it so amazingly weird and cool, and you just draw with a math function. This is crazy. I love that. So I have the mouse variable. Now what I need to do, I can just multiply something with the, probably just to see if this is working, ups mouse x, and I should declare the uniform here. It's 2 mouse. Yeah, so it goes from 0 to 1 and I see this. So what else I can do? Instead of multiplying this with mouse X, I can do this. I can control the red channel of my image, of my final image. And I can do this. I can subtract mouse X multiplied by something like this, for example. Let's try it. By absolute value, because mouse goes from 0 to 1 now. From -1 to 1, I mean. Okay, I think this is way too small, maybe like this. So the closer the mouse gets now to the screen, the more reddish it gets, because it just subtracts all the red parts of the channel right now. I get closer to the screen, it starts to glow red from the inside out, and it glows red from the inside because the closer the pixel is to the center of the object, the closer to the pink or purple palette of my get color function. So it's right now it's kind of bleak, but now if you go to the center, it gets brightness. And this is it. I could also add a bit of a mouse movement here, and mouse movement here is going to be in terms of changing this vector position, like this P. So I want to do Px plus equals mouse X multiplied by something like this, probably. I can move my object a bit, and Py probably vice versa, and I'm gonna change it. Hello. So there you go, you have it a bit moving, you have it rotating. We could also change the camera position. Now it's static, but we could add something like this, plus multiplied by sine times divided by 4. So the camera will get a bit closer to the object, and it's gonna get bigger and small. It's gonna be pulsating like this. This is crazy stuff, and it looks beautiful, and we still we have all those 60 FPS still. This is actually a pretty rare occasion where somebody using Raymarching technique in production, because it was considered not so performant. But in this particular case, it actually is, and it actually turns out pretty cool shape. So you can actually draw your own 3D shapes with just math. And remember when I told you that this whole object is just one function? And it actually is like 2 lines of code. This is the first line of code to describe this object, and this was the second line of code to describe this object. It's like the maximum between 2 functions. So essentially, this is what draws this weird shape on a screen. So this is it. This is what I wanted to show you. Hope you liked it. I hope you got the idea of how this actually works for you, because I think this is pretty cool. Raycasting on JS. Yeah, we could do that, but this is already getting pretty weird with the Raymarching now, so I don't even know if it's worth to do that. And we also could change the shape at any given point. We could change the coloring to the old coloring. Just get color with the diffusion again, lightning. Maybe just like this. So you can see the shape colored in like another weird. So this is actual shape trying to be colored. Maybe I don't know how far we could go with those streams, but they're probably much simpler stuff, which is also amazing, because the Raycaster is being pretty narrow field to describe. So I can change again to this color, and I like it more. Oh, not this one. Should remove this one. Just the glowing thing. Yeah. Pretty cool, I think. Well, you could just replicate that. I think it doesn't pay off for people to be lazy, that they just can, take the code and they will not do anything. I would like you to try. If you want to do this, you should just try this. It's not much of a code really, it's 100 lines of code, and I was spending 1 hour, more than 1 hour describing them. So if you like that, you can support me on Patreon. I don't have any kind of other donations yet. Whoa, I have a lot of, and I want to thank all of guys who supported me. I really do with Mario. I will probably write this in English now because I'm only streaming in English for now. I'm gonna spend all those money on something cool. Or maybe I just buy an ice cream for myself. I don't know. But thank you for all the support. It really makes me cry sometimes, you know. So somebody takes care of me. Please wanna get me some money. So like it inspires me to do more of those tutorials. Okay, thank you. I always thought that I was carrying you in games, but okay. So that's it for today. If you want to support me, support. If you want to thank me, thank. I wish you a good day. It was a pleasure being with you today. Hope you liked that. This is a pretty crazy stuff. See you next Sunday, hopefully. Also, if there's somebody is from Vienna, I just recently been speaking at Vienna React Vienna meetup, and I want to thank all the guys who've been there. And if you are from React Vienna and you're here, just say hi. Alrighty. I will make up for the national alerts probably on next stream. See you guys. Have a nice day.